Yes, madam.
Okay. Nishapriya, what is the meaning of matter? What is the meaning of matter? Say yes or no. Umesh, you know what is the meaning of matter?
Yes, madam.
What is the meaning of matter?
Matter means the particles or the air which are in our environment.
Occupies some space in the volume. Okay. Matter is exist in three states: solid state, liquid state, and gaseous state. Okay. And based upon the physical state, matter is classified into three types: solids, liquids, and gases. And also, based upon the chemical composition, matter is exists in two types. One is pure substance, and another one is mixtures. You know what is the meaning of pure substance? Anybody? Kushapriya.
Mixture is made up of two components,
Kushapriya.
madam.
What is the meaning of pure substance?
Pure substance is a substance which consists of single type of substance,
Pure
ma'am.
substance means it contains only one kind of atoms. Examples of pure substances: gold, silver, hydrogen, nitrogen, and water. These are the examples of pure substance. And you know what is the meaning of mixtures? Anybody? Umesh, what is the meaning of mixtures? Okay, it is the combination of elements, compounds. So, two or more elements, compounds means that is called mixtures. Okay. Now, based upon the chemical composition, matter is classified into two types: pure substances and mixtures. This one, pure substance, again classified into two types. That is called elements and compounds. So, you understand? Pure substance is again classified into two types. One is elements and another one is compound. So element means only one kind of atoms are present. So for example, gold contains only one kind of atoms. That means only gold is present, not there in silver and platinum. So element means only one kind of atoms are present. Example, hydrogen also. Hydrogen gas means only one kind of hydrogen atoms are present. So element means only one kind of atoms are present and it is a pure substance. You understand? Next, another one is compound. What is the meaning of compound? Anybody? Sumaya? What is the meaning of compound? What is the meaning of compound? Compound is also pure substance. Okay. Compound is also pure substance and it contains different elements and different molecules also. Example of compounds: water and acids and bases is the examples of compounds. Now you understand? Pure substances means examples, elements and compounds.
Yes,
Okay,
ma'am.
you understand?
Yes, madam.
What is the meaning of
Yes, ma'am.
mixtures? Mixtures.
Yes, madam.
Again I repeat. So based upon the
Yes,
chemical
ma'am.
composition, matter is classified into two types. One is pure substance and another one is mixtures. Pure substance again classified into two types: elements and compounds. Now mixtures. So what is the meaning of mixture? What is the meaning of mixture? Okay, Umesh.
Madam Ushapriya, ma'am.
Okay, very good. Mixture means it is the combination of different types of substances. So mixtures are two types: homogeneous mixture and heterogeneous mixture. What is the meaning of homogeneous mixture? Okay. Okay.
Madam Ushapriya, ma'am. Madam, homogeneous mixture is a mixture which is having uniform composition, ma'am.
Mixture means a uniform mixture, only single. It look like a single solution. Example of homogeneous is sugar water and salt water. These are the example of homogeneous mixture, uniform mixture. Next
Jahnavi madam.
What is the meaning of it? So non-uniform
Is a
means
mixture
example
which
soil water
has
and
non-uniform composition, madam.
juice, that is lemon juice. So it is the examples of a heterogeneous mixture. Okay, you understand? Next, what is solution? Anybody know? What is the meaning? What is solution? Next,
Yes, madam.
basic. What is the meaning of solution?
Madam, tell
Ushappriya,
madam.
ma'am.
Jayshree? Okay, Ushapriya, what is the meaning of solution?
Madam Ushapriya ma'am. The combination
Okay,
of
very good.
solvent
The
and
solute plus
the
solvent
combination
equal
of
to
solvent and
solution.
solute
For
particles is
example,
called
sugar
solution
water.
ma'am.
Sugar water is a solution. In this sugar water, solute is a sugar and solvent is a water. So which substance is present in solution? Less amount. Which substance is present in less amount in solution? That is called a solute. So sugar is present in a water less amount. So sugar is a solute and water is present more amount in sugar solution. So water is called a solvent. You understand? Less amount means solute and more amount means a solvent. So in sugar solution, sugar is less amount. So sugar is called a solute and water is more amount. So water is called a solvent. So solute plus solvent equal to solution. You understand? What is the meaning of solution? Solution means solute plus solvent equal to solution. Okay, next. Based upon the size of
Yes,
the
madam.
solute particles, solutions
Yes,
are two
madam.
types. One is true solutions, second one is colloidal solution, and third one is a suspension solution. You understand? So based upon the size of the solute particles, solutions are three types. That is true solutions, colloids, and suspension. So first of all,
Yes,
what is
madam.
the meaning of true solution? True solution means the size of the solute particles is very less, very small. So in true solution, example sugar solution.
Jahnavi
It
madam.
look like a single solution and it is a homogeneous solution. You understand? You understand, yes or no? So true solution. So based upon the size of the solute particles, solutions are the three types.
Yes,
True
madam.
solutions, colloids and suspension. True solution means sugar solution. The size of the solute particles are very less and it look like a single solution and it is a homogeneous solution. Next, colloids. Colloids is a homogeneous or heterogeneous solution? Heterogeneous solution. Very good. So colloids is a heterogeneous solution. Example milk. These are the examples of colloidal
Heterogeneous
solution.
madam.
Next, suspension. Suspension is a homogeneous or heterogeneous suspension? Heterogeneous mixture. And example is chalk piece water and sand water is the example of suspension solution. You understand this one? Homogeneous, heterogeneous mixtures and next solutions, types of solutions based upon the size of the solute particles. So now I show Tata class section. You not understand this? Now I show Tata class section. Okay? Okay. Now you see Tata class.
Okay madam.
Okay, madam. Okay, madam. Done.
Mixture and its types. what is mixture and what is pure substance? Yes or no? Okay. Now I show Tata class. So what is the meaning of mixtures?
In our daily life, we come across many substances like tap water, salt, sugar, milk, honey, gold, silver, etc. These substances are basically classified into two types: pure substance and mixtures.
What are the two types? Elements and compounds. And mixtures also again classified into two types. That is homogeneous and heterogeneous.
Salt, sugar, gold and silver are examples of pure substance, while tap water, milk and honey are examples of mixtures. A pure substance has the same kind of atoms or molecules and definite set of physical and chemical properties. Then, what are mixtures? Observe a solution made up of water and sugar. Is this solution a pure substance? No, it is not a pure substance, as it is obtained by mixing of two pure substances, water and sugar.
Sugar solution is a pure or mixture? Sugar solution is a pure or mixture? Mixture. Sugar solution is a mixture. So water is a pure substance. Sugar also pure substance. But it is the combination of water plus sugar equal to sugar solution.
Mixture, ma'am.
It is a mixture.
Mixture, madam.
Mixture is the combination of two or more pure substances form mixtures.
Yes, madam.
Thus, two or more pure substances mixed together in any proportion without undergoing any chemical change by retaining their individual properties forms a mixture. The substances which form mixtures are called components or constituents of mixture. Thus, sugar and water are the constituents of sugar solution. Let's now look at the different types of mixtures in day-to-day life. Consider a mixture of raw rice and powder. Mixture consists of either atoms or molecules. For example, mixture of iron and sulfur powder is made up of atoms of sulfur and iron, while air is made up of molecules of oxygen, nitrogen, carbon dioxide and water.
Sulfur and iron. Next, combination of oxygen means, for example, air. Air means it is the combination of oxygen, nitrogen, carbon dioxide and water molecules. So, air is a homogeneous mixture or heterogeneous mixture? Air is a homogeneous or heterogeneous? Heterogeneous mixture. Because air is look like a homogeneous mixture, but it contains a number of chemicals, next gases, next
Heterogeneous, madam. Heterogeneous, madam. Heterogeneous
so
mixture,
air is
madam.
a heterogeneous mixture. Next.
Homogeneous but heterogeneous.
Mixtures have components of varying proportions. Substances in different forms that are solid. Let's recapitulate what we have learned.
Separation means divided.
Okay, madam. Okay, madam.
A mixture is a combination of two or more substances. For example, a mixture of potassium permanganate in water, a mixture of water and milk, and a mixture of mud in water. But do all these mixtures have the same properties? Well, the answer is no. In this animation, you will learn about the properties of different types of mixtures. Mixtures can be classified into three types depending on their properties: solutions, colloids, and suspensions. Let us look at the definition of each of these types. A solution is a homogeneous mixture of two or more substances. By homogeneous, we mean a solution that is uniform in structure or composition throughout. For example, a solution of potassium permanganate in water. A colloid is a mixture that contains finely divided particles suspended in the solution. These particles cannot be separated by filtration or sedimentation. For example, a diluted solution of milk. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. The solute particles are visible to the naked eye. By heterogeneous, we mean a solution.
Yes, madam.
It is a homogeneous mixture or heterogeneous
Madam.
mixture?
Yes, madam.
Colloid is a homogeneous or heterogeneous? Heterogeneous mixture. And example of water and milk. And the suspension example is mud and water. It is a homogeneous mixture or heterogeneous mixture? Suspension is a homogeneous or heterogeneous mixture? Heterogeneous.
Heterogeneous mixture. Heterogeneous mixture, madam. Heterogeneous mixture, madam.
That is not uniform in structure or composition throughout. For example, a muddy water suspension. Let's compare the properties of these different types of mixtures. Solutions, colloids, and suspensions have different properties. Note the appearance of each mixture. A solution of potassium permanganate in water appears clear, transparent, and homogeneous. A diluted solution of milk appears cloudy, but uniform and heterogeneous. It contains particles of the colloid dispersed in the solution. A muddy water suspension appears cloudy and heterogeneous, and the suspended particles are easily visible. Now, let's learn more about the particle size in each type of mixture. A solution contains a solute made up of atoms, ions, or small molecules dissolved in the solvent. The particles are too small to be visible to the naked eye. These particles cannot be separated by filtration or sedimentation. They are separated by distillation. Colloids contain larger molecules dispersed in the solvent. These particles are not visible and cannot be separated by filtration or sedimentation. They are separated by centrifugation. A suspension contains large particles that are initially suspended in the solvent but settle down quickly if left undisturbed for a while. These particles are easily visible and can be easily separated by filtration or sedimentation.
Jahnavi,
Some mixtures scatter a beam of light
what is the meaning
due
of Tyndall effect?
Yes, madam. Yes, madam.
A beam of light
Yes, madam.
pass through a colloidal solution. So light is so in that time light is visible. That means
Yes, madam.
Tyndall effect. So Tyndall effect is observed in
When a beam of light is passed
so
through a colloid solution.
you not understand means now I show Tata percent. Okay, what is the meaning of Tyndall effect? Tyndall effect means when a
Colloid
beam of light
solution.
passes through a colloidal solution, the light is visible. That is called Tyndall effect.
to small particles in the medium. This is called the
Okay, madam.
Kindle Effect. Let's see what happens when we shine a beam of light on each type of mixture. Light passes through solutions without the path of light being visible in the solution. So, there is no scattering of light, and consequently, solutions do not show the Tyndall effect. The path of light is visible in colloids because colloidal particles scatter light. So colloids show the Tyndall effect. Particles of a suspension settle down due to gravity. So the effect of light is variable depending on the suspension. If the particles of the suspension continue to remain suspended, the Tyndall effect can be observed. However, if the particles settle down, the solution above the particles will be clear and will not scatter light. Let us summarize the property.
First one is sublimation. You know what is the meaning of sublimation? Anybody know sublimation? Okay. Okay, Vrishapriya, what is the... Okay. All of you go to mute. Only Vrishapriya. You only explain. What is the meaning of sublimation? Okay, the solid directly changes.
Vrishapriya, ma'am.
Yes, madam. So the sublimation is observed in camphor, naphthalene bars and ammonium chloride and
Madam.
iodine. So sublimation only observed in these only substances or
The
remaining
conversion of the
substances also
substances solids to gaseous
substances only
directly.
or remaining substances also sublimation is observed. Say yes or no? This substances only observed. This iodine, camphor, ammonium chloride, naphthalene bars only observed in sublimation process. That means the solid directly changes to gaseous state. So how to separate sublimation process? You know what, how to separate sublimation to different
substance only, madam.
For example, salt and camphor mixing. So how to separate the salt from camphor? How to separate the salt from camphor? Next, another
Yes.
separation technique is first you know what is miscible liquids and what is immiscible liquids. Anybody know what is miscible and what is immiscible liquids?
Madam,
Janna,
Varshita madam.
what is the meaning of miscible and immiscible liquids? Anybody know? Okay. Now I explain. Miscible liquids means one liquid is completely dissolved in another liquid, that is called miscible liquids. For example, water and alcohol. So these are completely dissolved in one to another. So that is called miscible liquids. So how to separate both liquids are completely dissolved
madam.
in one and another? How to separate? The separation technique is distillation. Distillation is used for the separation of two miscible liquids. One liquid is completely dissolved in another liquid to separate the distillation process. So distillation process is used for the separation of miscible liquids distillation process. You understand? Yes or no? So distillation process is used for the separation of two miscible liquids based upon their boiling point. What is the meaning of immiscible liquids? Anybody? What is the meaning of immiscible liquids? One liquid is not dissolved in another liquid, that is called immiscible liquids. Example, water and oil. So water and oil are both are immiscible to one another. Both are not mixed to one another. And you take one separating which method is used for the separation of two immiscible liquids? That is called separating funnel. Separating funnel is used for the separation of two immiscible liquids. You take the mixing of water and oil and shake it. So what happened? The oil is formed in upper layer and water is formed in a lower layer because the density of water is high compared to oil. So oil is formed in a upper layer and water is formed in a lower layer. So open the tap means the water is collected and oil is left behind the separating funnel. So what is the basing of the separation of these two immiscible liquids? Based upon their densities. Okay, you understand? So based upon their densities, two immiscible liquids can be separated to separating funnel. You understand? You don't understand? Okay, you don't understand means now I show the data class. Okay?
Yes, madam. Yes, madam. Yes, madam. Okay, madam. Okay, madam.
So separating the different types of methods. So using the separating techniques. So what are the different types of methods to using the separating techniques? One is sublimation, another one is distillation, and another one is separating funnel.
We come across several mixtures in our day-to-day life. Depending on the type of mixture, we use different methods to separate the components of.
Understand means now I show data class. Okay, first technique. Already you learn in lower sections using the data class section methods of separating components of mixtures. Okay, first one is filtration, segmentation, decantation, and evaporation also.
The mixture. In the lower classes, you have studied how to separate the components of a mixture by using filtration,
So separating funnel.
sedimentation, decantation, and evaporation. Let us now look at other methods of separating the components of a mixture. Note that water being denser forms the lower layer and oil being lighter forms the upper layer.
Next one is crystallization.
Now, open the tap at the bottom of the separating funnel to let the water run out. Empty the upper layer in a separate container. The principle used for separation of immiscible liquids is also used in the extraction of iron from its ore. The process of separating a pure solid in the form of its crystals from a solution is known as crystallization. Let us see how to obtain pure copper sulfate from impure copper sulfate. Take the impure copper sulfate and dissolve it in minimum amount of water. Filter the impurities from the solution.
So in this process, pure crystals are left behind a China dish. So evaporation technique is used for the separation of pure copper sulfate from impure copper sulfate. Next technique is
Evaporate the water in a china dish to get a saturated solution. Cover the solution in the dish and allow it to cool slowly for a day.
the solid is directly changes to gaseous state.
Crystals of pure copper
State of liquid, that is called sublimation. In this process, the mixing of salt and camphor is taken in a china dish and heated continuously. And first camphor is evaporated and
Sulfate
salt is
are left behind in the china dish. Crystallization is used in the purification of salt and alum. Certain substances change directly from the solid state to the gaseous state on heating. Such substances are called sublimable substances. A sublimable volatile component is separated from a non-sublimable impurity by the process of sublimation. Let us see how to obtain iodine from a mixture of iodine and salt. Take the mixture of iodine and salt in a china dish. Place an inverted funnel over the china dish. Close the open end of the funnel with a cotton plug. Heat the mixture until iodine sublimes and the violet vapors condense around the cooler parts of the funnel. Salt is left behind in the china dish. The process of sublimation is applied.
Yes, madam. Yes, madam.
We come across several mixtures in our day-to-day life. Depending on the type of mixture, we use different methods to separate the components of the mixture. In the lower classes, you have studied how to separate the components of a mixture by using filtration, sedimentation, decantation, and evaporation.
111 degrees centigrade.
Let us now
So first pentane is evaporated and left behind the beaker, and toluene is present in distillation flask. So in this process, based upon the two
pentane has a boiling point of
36 degrees centigrade, and then one is 111 degrees centigrade. So distillation process is used for the separation of based upon the boiling points of two liquids.
36 degrees centigrade and toluene has a boiling point of 111 degrees centigrade. grade. Distillation is the method of choice for separating miscible liquids having a difference of at least 25 degrees in their boiling points. Heat the mixture in a round bottom flask. Pentane with a lower boiling point vaporizes first and passes through the water condenser. The vapors of pentane are cooled by the circulating cold water in the condenser. The condensed distillate is collected in a collection or condensation flask. Toluene is left behind as the residue in the round bottom flask. Thus, pentane and toluene are separated from the mixture. Distillation.
Yes, madam. Thank you, madam. Thank you, madam.
Thank you, madam.